Hi, I'm Ms Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. In x notation, the new rule we have is the derivative with respect to x of the natural log of x is equal to 1 over x. Okay, remember all this u notation is it incorporates the chain rule into the notation. So what we're saying is if you take the derivative with respect to x of the natural log of any function u, that's going to be 1 over that function, 1 over u, times the derivative of that function with respect to x. It incorporates the chain rule right into the formula. It's not necessary because we know the chain rule, but a lot of times the books give you that version of the formula just as a more general formula. All right, so let's try to apply this idea. We're going to find the derivative of y with respect to the independent variable, which in this case is x. So we're looking for dy dx, okay? So taking the derivative, we have the derivative of y with respect to x is going to be equal to what? Well, in the first term, we have the natural log of 3x. So we don't just have the natural log of x equals 1 over x. We have a 3x instead of the u there. And that's okay, because by the chain rule, we know that we have a composition here. The 3x is the inside function, the natural is the outside function. So we're going to take 1 over the 3x, just as we would have if it were just an x. But we're going to multiply by the derivative of 3x, which is what this du dx here represents in the formula. Okay, plus the derivative of x is just 1. Now I've got another step to go here. So that means that it's 1 over 3x times derivative of 3x is just 3 plus 1. 1 over 3x times 3 is actually 1 over x, so we get 1 over x plus 1, and we're done. All right, so any questions about any step in this process, getting from here to here, or here to here, or to here? Okay, you see how we use the chain rule in the process of this problem? It's going to be in almost every problem is going to involve a chain rule of some sort. So it's really important, if you're not comfortable with the chain rule yet, that you start to get comfortable with. And you will. It just takes practice and time. Okay, let's find the derivative of y equals t times natural log of t quantity squared. Again, they tell us to find the derivative with respect to the with respect to the independent variable, which is t in this case. So we're looking for dy dt this time. Okay, but does anything stand out about this problem? A composition, that's right. We have one function inside of another. If you look right here, we have a composition. So we know a chain rule is going to be involved. Now, it's not the whole thing being raised to the second power. It's only that second part, right? So before we deal with that, we have to deal with the fact that this is a product. So we have a first function and a second function. So we're going to have a product rule. First times derivative of the second plus the second times derivative of the first. So let's go off to the side and figure out what our f prime and s prime would be. So if f is equal to t, then f prime is just going to be 1. And if s is equal to the natural log of t squared, let's figure out what s prime is going to be. All right, since it's a composition, we need to use the chain rule. The first thing is the outer function, the squared. So you refer back to the rule, same rule you would use for the derivative of x squared. It would just be 2x, right? So this is going to be 2 times the natural log of t. But since this is not just a t, we are going to have to multiply by the derivative of the natural log. So we have 2 times the natural log of t times, and now we're going to use our rule that we just learned. What's the derivative of the natural log of t? Good, 1 over t. Or you could write it 2 natural log of t over t just to be a little bit more compact. All right, so now I'm going to put in my f, my s prime, and so on. So I have dy dt equals, and then we're going to have t times s prime, which is 2 natural log of t over t, plus natural log of t squared times f prime, which is just 1. So dy dt is equal to 2 natural log of t plus natural log of t squared. Any questions about that problem? Okay, so since we're still getting comfortable with the chain rule, I just want to point out, yes, it's done. Let me put this in a box so we know we're done. You could factor out a natural log of t and write it as natural log of t times 2 plus natural log of t, but that's equivalent. Okay, so I wanted to point out to you that this is different, and I must have been using my bad pen the day that I wrote this. Let me fix it. Different than if we had y equals t times the natural log of t quantity squared. If we had that, then we would have to deal with the composition first. So what I mean by that is dy dt, you would first have to bring the power out front and subtract 1 from the exponent, and then multiply by the derivative of t times the natural log of t, which of course would require a product rule. So you would have 2t natural log of t times, we would have the first function and the second. Derivative of the first would be 1. Derivative of the second, derivative of natural log of t is 1 over t. So you would have the first function t times the derivative of the second, 1 over t, plus the second function natural log of t times the derivative of the first, which is just 1. So you would get 2t natural log of t times 1 plus natural log of t. All right, so two very different problems depending on where that power is located. So now let's look at finding the derivative of y equals a natural log of x cubed. And we're going to do this in two different ways, which is what we're going to do in the next video. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.